Okay, so my dear students, let's get started then. Now, today we will be learning about the periodic table. Let's have a look at it then. Now, what do you know about the periodic table? Have you ever seen one or maybe used one? Now, the periodic table is basically a table with all of the elements arranged accordingly, whichever the elements that have been discovered so far by scientists. Now, it's as you can see in this, it's actually color coded and it is grouped. So each of these color represents a particular group. Now, in this set of slides, you'll be able to know why they are grouped and why they are color coded, what each group means, what each of these elements are, and so on. So let's see. The periodic table is a chart of all known chemical elements. It helps scientists understand how elements behave by itself and with one another. Who created this periodic table? It was created by a scientist named Dmitry Mendeleev in 1869, which is way, way long ago. So, this periodic table is a table of elements arranged in a special order, like I mentioned earlier. Each element has its own square, showing its atomic number, its chemical symbol, and element name. So, if you consider this particular square here, H is its chemical symbol. H is hydrogen. I'm sure you have heard of hydrogen before. Hydrogen is a gas you can find in the atmosphere. Hydrogen has the chemical symbol capital H and it has the atomic number 1. And you can see here the below number, it's 1.006. You don't have to pay much attention to that for your level right now, but for your information, it's the relative atomic mass number of this particular element. So each of these elements have their own unique atomic number and their own unique mass number, as well as their own unique chemical symbol. So you have to know that each of these elements have their own atomic number and they are arranged according to this atomic number. So you can see here, starting with the one I labeled, it starts with 1, goes as 2, 3, 4, 5, 6, likewise up until 118 over here. So then, what does this atomic number mean? It actually means the number of protons in that particular element. So we will look at what these protons are, but for now just know that it's the atomic number or the number of protons in that particular element. Then moving on. How is it organized? Periods are the rows. Periods are the rows from left to right. So in a periodic table, usually there's around 7 periods. It goes from left hand to the right hand side. Groups are actually the columns from top to the bottom. These are groups. And there's about 8 groups. Now, elements in the same group share the similar properties. Remember earlier we saw it was color coded. In here also you can see this light blue color group here. It's the first group of the periodic table. It's labeled as the group 1. Each group 1 element has similar properties. So for example, group 1 elements are all very, very reactive. That's why they are all organized in this particular group. Likewise, it applies to all of these groups. So for example, group 0 here, HENEARKRXCRN. These set of elements, they are all unreactive. You call them the noble gases. They are all unreactive. So hence, they are all grouped in group number 0. So the last group, it's actually labeled as group 0 in some periodic tables. In some periodic tables, it's labeled as group 8. Both mean the same thing. Then, types of elements. So now, if there's 3 types of elements in the periodic table. We have the metals, we have the non-metals, and we have the metalloids. In this periodic table, you can see only 3 colors. You can see blue color, you can see gray color, and you can see green color. So, metals are all of it that's found on the left side of the periodic table. But there's an exception, which is hydrogen. Hydrogen, although it is on the left-hand side, it's the only exception where it is actually a non-metal. That's the only non-metal which is on the left-hand side of the periodic table. Other than that, every other element on the left-hand side of the periodic table are metals. Metals are good conductors of heat and electricity. They are shiny or very lustrous in nature. When you look at it, it's not dull. It's very shiny looking. And like I said, they are found on the left side of the periodic table. Non-metals, on the other hand, they are found on the right-hand side of the periodic table. You can see the green color ones, including hydrogen. They are very dull. They are brittle. That means they break very easily. They are poor conductors of heat and electricity. Not all. Most of them, they cannot conduct heat and electricity. They are very poor at it. And like I said, they're found on the right-hand side of the periodic table. Now, what's metalloids? Metalloids are elements which have properties of both metals and non-metals. Some they do conduct electricity, some they don't. Some are shiny, some are brittle, some are like dull. So you don't know which one is which, but they have properties of both metals and non-metals. And they are found in a zigzag line in the middle of the periodic table. You can see this ash color set of elements. This is the zigzag line over here. So boron, silicon, As, tellurium, these set of elements are the ones that fall under metalloids. Other than that, right-hand side to the zigzag line, you can see the non-metals, and to the left-hand side, you will see the metals, except for hydrogen, which is considered a non-metal. Then, groups to remember. Now, each of these groups you saw in the periodic table, they have certain names, they have their own features, their own, their own properties. But for your level, you can remember these three groups. Group number 1. Group number 1 is called the alkali metals. They are very reactive, as we saw earlier, especially with water. So sodium is one of the elements you find in group 1, falling under alkali metals. It's very, very reactive with water. Group number 7, the one before the last. So it's like this. You must be wondering why it's group 17 and group 18, but earlier we only saw group 1 to 8. Let's see why that is. Now, let me show you the periodic table over here. Now, some periodic tables, they label their groups this way. They take into consideration these transition elements, these transition metals as well. Some periodic tables, they do not consider these transition elements, these transition metals. So, that's why we see the difference. So, in this case, they don't consider these set of metals, they straight away go group 3 over here. But in the previous one, they consider this as well. Therefore, these set of metals will have group numbers 3 to 13, 3 to 12. From here onwards, it's group number 13, 14, 15, 16, 17, 18. But if you don't consider them, if you don't consider this, then your set of Groups are going to be 1, 2, 3, 4, 5, 6, 7, and 8. So in the slide, why it mentions group number 17 and 18 is because they have taken into consideration this kind of a periodic table. Hope that clarified. Now, let's see. So the group 17 or the group 7 in some periodic tables, it's group 7. In some other periodic tables, it's group 17. It's called the halogens. We name them halogens. Halogens form salts which are very reactive. So an example of a halogen is the chlorine, element chlorine. Chlorine is very reactive and they form salts. For example, the main salt that we use daily at home, sodium chloride, table salt, has the formula NaCl. So it has reacted with sodium, chlorine has reacted with sodium to form NaCl. So the table salt that we use on a daily basis at our household is iodized table salt, iodized NaCl. Then the final group or the last group on the right hand side of the periodic table, it's the noble gases. We call them the noble gases. They are unreactive. They do not react with other elements. They are very, very unreactive, not at all reactive. That's why we call them the noble gases. Some of the examples are helium gas and neon gas. Then, periods to remember. Now, periods, we know they are the rows on the table, and there are 7 periods in total in the whole periodic table. As you go across a period, the properties of elements slowly change. So, for example, now we know metals are on the left-hand side, non-metals are on the right-hand side, and on the middle, we have the metalloids. So, as you go across a period, on the left side, you have metals. As you go by, following the group number, you will notice that the properties of them slowly change. Left-hand side, we have the metals. Now, suddenly on the right-hand side, we have the non-metals. So, what you have to remember is that as you go across a period, the properties of elements slowly start changing. It's not the case for groups, because as you go down a group, the groups, they usually have similar properties. That's why they are grouped together. So it's not the case for period. As you go across a period, their properties change. Now, a fun fact. The first element, hydrogen, is the lightest element discovered so far. Gold and silver, the ones we use for jewelry, they are pure elements that you can find on Earth. Now, most of these elements, they are actually not pure. They are not very pure. They are either in their salt form or they are mixed with something else, likewise. So, 2 of the pure elements you can find in Earth are gold and silver. The periodic table has over 100 elements. To be exact, there's 118 elements, and new elements are still being discovered. So this 118, the number could change anytime. So here's a quick quiz for you to solve. What does each element square show? We saw the chemical symbol of that element. We saw its atomic number. We saw its mass number. And some periodic tables, the square actually shows the name of that element as well. So it shows the atomic number, it shows the chemical symbol, and it shows the element name. That's what an element square in the periodic table shows us. Next question. What's the difference between metals and non-metals? So you can talk about what it looks like. You can talk about their whether they are good conductors of heat and electricity, likewise. And where they are located, you can say they are located in the left-hand side or the right-hand side of the periodic table. Several differences I have taught you so far. So you can say metals are good conductors of heat and electricity, while non-metals are poor conductors of heat and electricity. Then, which group has unreactive gases? So I taught you all three distinct groups to remember their properties and their names. We learnt about group 1, the alkali metals, which contain the most reactive elements. And then we learnt about halogens, again the ones that form salts. The one I taught about table salt. Then like chlorine, known as halogens. And the last group number 8 or group number 18, was the unreactive gases, the unreactive set of elements. Examples were helium and neon. So if you recall the name, it's called the noble gases. Yes. So which group has unreactive gases? Group number 8, group number 18, or group number 0. All three of them are the same. Then, yes, that's it for today. Hope you all understood everything. And yes,